Hello everyone. In this video, I am revisiting the concepts of prime factorization and lowest common multiple LCM and highest common factor HCF. Let's take a look at this question. First and foremost, let's do A. A involves prime factorization using index notation. Okay, so I'm going to do both, one on this side and the other one on this side. Okay, all right. So when we do prime factorization, we have to make use of prime numbers and repeated division. So 40 divided by 2, the smallest prime number is 2. So 40 divided by 2 is 20. 20 can still be divided by 2, that gives us 10. 10 can be divided by 2, that gives us a 5. 5 cannot be divided by 2. 5 cannot be divided by 3. So the next bigger prime number would be 5 itself. And we stop when we arrive at number 1. So the numbers here would be known as the prime factors of 40. Right? So when we multiply 2 times 2 times 2 times 5, that gives us 40. So to write 40 as a product of its prime factors, we should have 40 is equals to 2 to the power of 3 times 5. Okay, so it's quite easy to understand. Let's move on to the next one, which is 64. So again, using repeated division, we have 32. Let's move on again, we get 16. Move on, we get 8. And we are having all the even numbers, so we can still proceed by using the smallest prime number 2. Okay, I have to stop because we arrive at 1. Okay, so again, the list on the left would be the prime factors of 64. Okay, so 64 is actually equal to 2 to the power of 6. That means 2 times 2 times 2 times 2 times 2 times 2 gives us 64. Okay, so we have completed going through prime factorization. Let's move on to part B, LCM, in the next slide. Okay, now to find LCM of 40 and 64, we have to present both 40 and 64 together side by side using repeated division. They have to be put side by side because we want to find a common multiple. So when it's a common multiple, means we have to compare both at the same time. Okay, all right, so when we put 40 and 64 in the repeated division symbol side by side, we just proceed as per normal by dividing it by the smallest prime number, which is a 2. So if divided by 2, 40 divided by 2 give us 20. Let's now do the 64. Gives us 32. Both are even numbers, so I can proceed. Right? Now, 20 divided by 2, yes, gives us 10. 32 divided by 2 gets 16, so I can still proceed because 10 and 16 are still even numbers. We have a 2, we have 5, and 8. Now, this is an issue. Now, we can't stop now because to get LCM, we have to proceed until both ends at 1 each. Okay, so we have to continue because LCM means we want to get a very big number, bigger than 40, bigger than 64. That number, that same number, that common number must be able to be divided by 40 and 64. Right? That is the meaning of LCM, the lowest common multiple, a very big number, the smallest very big number that can be divided by both 40 and 64. So to find out, of course, we have to proceed. Right? We have to proceed further. So we can still divide by 2 because 8. But 5, what happened? 5 cannot be divided by 2. So we copy 5 down. Means don't do anything to 5. Okay? So 8, let's deal with 8 first. So 8 divided by 2 gives us a 4. Again, 5 cannot be done, so copy down. 4 can be divided by 2, right? So let's proceed. Right? Now, 2 divided by 2 give us a 1. And 5, nothing happens, so still a 5. But we will end very soon when we arrive at a 5, because the next one, okay, pardon me, I have no more space, so I'm going to do it up here. Okay, so we have like this. Let me copy down. So you have a 5 and a 2, right? Okay, so we have a 2 here that gives us 5, and this 2 we end at 1. So this one we can stop. But this 5 we can't stop, so we have to proceed with a 5. The aim is to get both 1, 1. That's the aim. That's our aim. All right? So when we get both 1, 1, it means that we have arrived at the LCM of 40 and 64. So what is the LCM of 40 and 64? It would be all this, including these two. Okay? So LCM of 40 and 24 will be 2 to the power of how many? Let's check. 1, 2, 3, 4, 5, 6, 7. Not 7. My apology. This is a repeat, so we cannot count this. Okay? All right, let's count again. 1, 2, 3, 4, 5, 6. Okay, to the power of 6, and then we have a 5. So the LCM of 40 and 64 is 2 to the power of 6 times 5. If you use a calculator, we should get a very big number, 320. And 320 is the LCM of 40 and 64. Remember, when we do LCM, we present both 40 and 64 on the same repeated division symbol, and we have to continue to do the repeated division until we arrive at both 1, 1. Then we can stop. Okay? Now, but HCF will be a different story. Let's take a look at the next slide. Now, for HCF, same. We have to present them on the same repeated division symbol, but we will stop when we cannot divide by the same factors any further, because of the word HCF. F means factors, so the factors are in control. Okay, so let's try. Okay, so smallest factor here is 20, right? Which is smaller prime number. So 20 and 32, I can proceed. Both are even numbers, so I can still proceed. I get 10 here, I get 16 here. This is as per normal like just now. So divided by 2, I get 5 and 8. Now, I have to stop already because I can't find a common factor that can divide these two. I can't. There's no more common factor that can be divided by 5 and 2. So we have to stop. So this alone would be the highest common factor of 40 and 64. And HCF of 40 and 64 would be 2 to the power of 3, which is the value 8. So remember, HCF is controlled by the prime factors in the repeated division. As for LCM, we have to proceed until we get both 1, 1. It means we have to proceed to do our repeated division until we arrive at 1 for all the numbers in the repeated division symbol. Now, I hope today's video revisiting prime factorization, LCM and HCF would be a clearer, better understanding. All right. My apology if my previous videos have confused you. I hope this one is a better, much clearer video to explain to you how to go about using prime factorization, index notation to answer questions involving LCM and HCF. Of course, plus the use of repeated division involving prime numbers. Now, if you like my today's revisited video, kindly give this video a thumbs up, share with your friend, right? And I really encourage your feedback, comments. Okay, all right. Now, do remember to subscribe to my channel, because then you will get to be notified of all my future videos being uploaded. Okay, so for more videos, you'll be notified, you'll be prompted once the videos are uploaded, only if you have subscribed. Thank you for listening, watching this revisited video on LCM HCF. Thank you for your support. And for those of you who have subscribed to my channel, thank you so much. This is Joseph. Goodbye.